Assalamualaikum warahmatullahi wabarakatuh. In this video, we will present about paper chromatography, which used to separate component in food dyes. Here are the fellow team members and the presenter.
First of all, let's start with the definition of chromatography. Chromatography is a technique used to separate the component of a mixture based on the rate at which they are carried through a stationary phase by a gaseous or liquid mobile phase. It is divided into two types of chromatography, which are absorption and partition chromatography. Absorption chromatography is where the analytes are separated based on their different degree of absorption on a solid stationary phase, while partition chromatography is the distribution by the dissolving of the component between two immiscible liquid phases. For absorption chromatography, its stationary phase is solid while the mobile phase can be either liquid or gas. Partition chromatography has the same mobile phase as absorption chromatography but different in stationary phase, which is liquid. Under partition chromatography, there is a paper chromatography, which is the type of chromatography that we will discuss in the next slide. So, in this video, we will focus on the paper chromatography. Paper chromatography is a technique used to separate low molecular mass compounds based on their distribution between stationary phase and mobile phase. It uses a sheet or a narrow strip of paper to serve as the stationary phase. Other than that, it is classified under the partition chromatography because the components that need to be separated are divided between the mobile phase, the solvent, and the stationary phase, which is water absorbed on paper. Then, paper chromatography is also categorized under the type of planar chromatography, including the thin layer chromatography (TLC). Planar chromatography stationary phase is supported on a flat plate or in the pores of a paper, while its mobile phase moves through the capillary action.
Next, I will talk about the theory of chromatography. Russian scientist Michael Tiswek, who was born in Italy, invented chromatography for the first time in 1900 at the University of Kazan. His success to obtain the separation of color substances into their component. He called the new technique chromatography because the result of the analysis was written in color along the length of the absorption column. The chroma means color and the graphene means to write. Then, we move on to the how paper chromatography works. The mixture is spotted onto the paper during paper chromatography, allowed to dry, and the solvent is then allowed to run along the sheet due to capillary attraction. The different components of the mixture separate into distinct colored patches as the solvent gradually absorbs the paper. After drying, the position of various components is visible. The paper chromatography principle states that the most soluble molecules on the filter paper go further than the least soluble one.
Principle of paper chromatography. Paper chromatography is partition chromatography. There are two phases. First is stationary phase and second is mobile phase. Stationary phase is to the absorb the mixture being separated. Meanwhile, mobile phase is passed through the stationary phase that carry the component. Stationary phase for paper chromatography is water trapped on the paper. Meanwhile, mobile phase is liquid solvent. For paper chromatography, as the solvent moving up, the paper will dissolve the component and move them up. The more soluble component is in mobile phase, the less absorbed by stationary phase, so component will move faster and further. But if component is less soluble in mobile phase, it's more absorbed by stationary phase, so it will move slower. Next is application of paper chromatography. First, to separate the component in mixture, for example, mixture of amino acid. Second, to analysis food color in synthesis drink, beverage, ice cream and sweet. Third, to separate the color pigment in plants. And fourth, to separate the component of ink and dyes, plant compound and many more substrates. In this video, the application of paper chromatography that we will focus is to separate food dyes.
First, a line parallel was drawn to the short dimension with 3 cm from the bottom edge of chromatography paper with a pencil. Then, 4 small X was marked along the line equally distanced or about 3 cm from each other. The bottom of each X was labelled with red, blue, green and yellow. The developing solvent was prepared by dissolving 2 grams of NaCl in 100 ml water, and about 70 ml of the solvent was poured in a clean dry 1000 or 2000 ml beaker. The chromatography paper was laid on the table. A tiny spot of each food dye was placed on each X marked by using a microcapillary. Repeated if necessary. Clamp or retort stand or either a glass rod or pencil were used. The paper was hanged and slowly immerse the paper in the beaker containing the developing solvent. Make sure that the paper does not touch the wall of the beaker, and also the level of the solvent is below the line drawn. The solvent was allowed to rise until about half distance, mid-length. The paper was taken out from the beaker. Lastly, the paper was dried for 5 to 10 minutes, then the line for the solvent front that has been marked was drawn.
Based on the experiment that has been conducted, we can observe that there are 4 different food dyes with their color components shown on the paper. We can identify them as pure or impure substances based on the separation. Hence, red food dyes produce 3 color components which are pink, red and yellow color. Blue food dye produce 2 color components which are purple and blue. Green food dye produce yellow and blue color components, while yellow food dye indicates that there is only 1 color component which is yellow. Therefore, we can conclude that blue, green and red food dyes are impure substances, while yellow food dye is a pure substance. For the calculations, we have calculated the RF value of each food dye. We use the formula whereby RF is equal to the distance solute moved divided by the distance solvent front moved, which is constantly about 4.8 cm. Thus, the result of each food dye are carried out as shown in the slide. Based on the RF value, red and yellow food dyes have a good value compared to blue and green food dyes because the impurities or other additive are resolved from each other. In conclusion, a chromatogram shows the soluble components that were present in the mixture. Based on our result, 1 color means that the substance is pure, while 2 color components or more is impure substance. The obtained result display that the yellow food dye on the right is a pure substance. This can be seen when separation occurred because of the water allowed the color components to move up. Based on the result, green food dye is more soluble in the mobile phase because it was the higher traveled compared to other food dyes, and it is a less polar solvent. To conclude, the higher the spot or color components move up, the more soluble the substances are.
Here are some references that we use to complete our video presentation.
That's all from us. Thank you for watching. Bye.